Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of engineering chemistry. We'll dive into key concepts like sources, impurities, hardness and its units. Let's get started. Slide 1. Sources of water. Let's begin with the sources of water. Sources of water refer to the natural and artificial origins from where we obtain water for daily use, industrial processes, and agricultural purposes. First source is surface water. This includes rivers, lakes, ponds, and reservoirs. It is easily accessible but contains many impurities like suspended particles, dissolved salts, and microorganisms. Example: water from the Narmada River in Madhya Pradesh. Second is groundwater. This water is stored under the earth's surface and is obtained through wells and borewells. It is usually cleaner because soil layers act as natural filters, but it can still contain dissolved salts. Third is rainwater. Rainwater is the purest natural source when it falls, but as it reaches the ground, it may collect dust, gases, and suspended impurities from the air. Fourth is seawater. It is the largest water source but has very high salt content, making it unfit for direct human consumption or industrial use without treatment. Fifth is glacial water. This comes from melting glaciers. It is extremely pure but not easily accessible to everyone. Sixth is municipal supply water. This is the water treated and supplied by local authorities for public use. The treatment process removes harmful impurities to make it safe. Seventh is spring water. This is water that naturally emerges from underground sources. It is usually fresh and less contaminated. Significance: understanding the source of water is crucial because the type and amount of impurities depend on the source, which in turn decides the type of treatment required. Slide 2. Impurities in water. Next, we will discuss impurities in water. Impurities are unwanted substances present in water that can make it unsuitable for drinking, industrial, or domestic purposes. There are different types of impurities. 1. Suspended impurities. These are insoluble particles like sand, clay, and silt. They make water appear dirty and can settle at the bottom. 2. Dissolved impurities. These are soluble substances like salts of calcium, magnesium, sodium, and potassium. These cannot be seen but affect water taste and quality. 3. Colloidal impurities. These are very fine particles of organic matter or clay that do not settle easily. They make the water appear muddy and turbid. 4. Biological impurities. These include bacteria, viruses, algae, and other microorganisms. They can cause waterborne diseases like cholera and typhoid. 5. Gaseous impurities. These are dissolved gases like carbon dioxide, CO, hydrogen sulfide, HS, and oxygen. For example, HS gives water a rotten egg smell. 6. Organic impurities. These come from decaying plants, animals, oils, or industrial waste. They cause bad taste and smell. 7. Radioactive impurities. These are traces of radioactive elements like uranium or radium, usually found in water near mining areas or nuclear plants. Example: dissolved iron salts are common impurities in groundwater. Significance: impurities in water affect human health, industrial operations, and agriculture, so they must be identified and removed. Slide 3. Hardness of water. Now, let's understand the concept of hardness of water. Definition: hardness is the property of water that prevents the formation of lather with soap. It is caused mainly by the presence of dissolved salts of calcium, Ca², and magnesium, Mg². Types of hardness. 1. Temporary hardness. This is caused by bicarbonates of calcium and magnesium, CaHCO, and MgHCO. It can be removed by boiling the water. 2. Permanent hardness. This is caused by chlorides and sulfates of calcium and magnesium, Cal, MgSO. It cannot be removed by boiling and requires chemical treatment. 3. Total hardness. It is the sum of temporary and permanent hardness. 4. Carbonate hardness. Another name for temporary hardness because it is associated with bicarbonates. 5. Non-carbonate hardness. Another name for permanent hardness because it is caused by non-bicarbonate salts. 6. Biological impact. Hard water is not harmful to human health. In fact, it contains essential minerals. However, it is not suitable for industries because it causes scaling. 7. Economic impact. Hard water increases costs in industries because it damages boilers, pipes, and consumes more soap. Example: well water from limestone areas is generally hard. Significance. Knowledge of hardness is necessary to decide the type of water treatment required. Slide 4. Units of hardness. Now, we will learn about the units used to measure water hardness. Hardness is measured to express the amount of calcium and magnesium salts present. There are several units. 1. ppm, parts per million. 1 ppm equals 1 part of Ca equivalent in 1 million parts of water. This is the most common unit used in laboratories. 2. Milligram per liter, milligrams per liter. Practically, 1 ppm equals 1 milligram per liter in dilute solutions. 3. Degree Clark, degrees Clark. 1 degree Clark equals 14.25 milligrams per liter of Ca equivalent. This unit is used in the UK. 4. Degree French, degrees French. 1 degree French equals 10 milligrams per liter of Ca equivalent. Popular in European countries. 5. Degree German, degrees German. 1 degree German equals 17.8 milligrams per liter of Ca equivalent. Used in Germany and surrounding regions. 6. Mec.L, milliequivalents per liter. This unit is used when hardness is calculated in terms of chemical equivalents. 7. GPG, grains per gallon. 1 GPG equals 17.1 milligrams per liter of Ca equivalent. Commonly used in the USA. Example: if a water sample has 100 ppm hardness, it means 100 milligrams of Ca per liter. Significance. Knowing units helps in comparing water samples and deciding the treatment process. Slide 5. Advantages and disadvantages of hard water. Let's discuss both the positive and negative aspects of hard water. Advantages. 1. Contains essential minerals like calcium and magnesium, good for bones and teeth. 2. Improves taste. Many people prefer the taste of hard water. 3. Prevents corrosion of pipes by forming a protective layer of scale. 4. Useful in leather tanning industry as certain minerals help in the process. 5. Helps in brewing beverages like beer, where mineral content enhances flavor. 6. Used in construction, slows down setting time of cement, improving strength. 7. Prevents leaching of metals from old pipes. Disadvantages. 1. Consumes more soap and detergents because it forms scum. 2. Causes scaling in boilers, heaters, and pipelines, reducing efficiency. 3. Decreases heat transfer efficiency in industries due to scale formation. 4. Damages fabrics during washing, making them rough. 5. Forms deposits in appliances like kettles and geysers. 6. Makes skin and hair rough after washing. 7. Increases maintenance cost in industries and homes. 8. Not suitable for laboratories and pharmaceutical industries. 9. Gives unpleasant taste if hardness is too high. Example: if you see white deposits inside your geyser or electric kettle, it is due to hard water scaling. Significance. Understanding these points helps in deciding whether to treat water or use it directly based on the purpose.